Hello, I am Joseph Burns, and I'm a managing principal with Thornton Tomasetti in Chicago. I plan to talk about the evolution in computational design that has happened in our industry, exploring where we have been, how did we get here, and where are we going. And so, where have we been? My timeline will describe what we make in the physical world above the line and what tools we use to achieve our goals below the line. I include shipbuilding because the tools shipbuilders used included a spline, a tool that had a significant impact on the invention of CAD systems and future automated tools. My timeline for building engineering begins in the mid-19th century, with Chicago claiming the world's first tall building. It had a modern steel frame, fireproofing, and elevators, all innovations from this period. Things got interesting in the engineering world as we entered the 20th century with the invention of automobiles and aeroplanes. Incredible innovation occurred over the first half of the century in architecture, automotive, and aerospace, while continuing to use hand drawings and calculations. The next 6 decades, from 1950 to 2010, is where there was tremendous innovation in computer-aided design for these fields, parallel with the development of semiconductors. The origins of CAD systems in the 1950s begins in France with Paul de Castelnau and Pierre Bézier developing algorithms for the shipbuilder's spline and digitizing these in early computer programs. And Chuck Eastman at Carnegie Mellon predicts our BIM future in 1974 with his seminal GLIDE program. In 1992, Frank Gehry's Fish in Barcelona is the first BIM architectural structure. By 2010, we have extraordinary 3D tools like Revit, generative components, and Grasshopper. This paralleled the improvement in hardware following Moore's law, predicting the doubling of components on an integrated circuit every 2 years. Chuck Eastman had a similar observation about our industry, that our AEC industry follows the aerospace industry by 2 decades. Yes, our AEC industry was drawing by hand for 2 decades following Boeing's use of CAD with the 747, and Frank Gehry's Fish notwithstanding, we primarily used 2D CAD contract documents for 2 decades after Boeing used BIM for their 777. The 787 launched in 2013, and what could our industry be adopting from it in the coming years? Soldier Field in Chicago is our first use of BIM software in the design and delivery of a project. We utilized Tekla's XSteel software to model all of the steelwork in a BIM model, and it became the contract document for steelwork in the bidding, shop drawing, and construction phases of the project. There were many challenges, but the advantages of the direct flow of steel design information to digital fabrication and ease of steel erection outweighed the challenges. With robots that cut and punch steel, even complex structures neatly fit together in the field. An added benefit was that the cladding was fabricated by Premistalisa, who was experienced in closing Frank Gehry's buildings. They used our Tekla model to carefully tailor the exterior enclosure to fit our structural frame. So how did we get here? Core Studio is Thornton Tomasetti's in-house R&D team. We continued to use BIM software like Tekla and CATIA after Soldier Field with Barclay Center in New York, allowing further development of modeling and collaboration tools. Our advanced computational modeling team evolved into our Core Studio by 2014, developing tools to achieve our goals. Our Core Studio operates like a startup, oscillating between making tools and using them with project teams. There are many tools and many projects, but here are 2 examples of projects and their tools. We were structural engineers for 30 Hudson Yards, but we also delivered the structural steelwork with Tekla while improving workflows between our analysis software, Tekla, and the rest of the design and construction team. The shed at Hudson Yards combined our structural and facade engineering teams with rapid design iteration and environmental analysis. And finally, where are we going? Here are 4 paths among many from our recent work that show promise: artificial intelligence, interoperability, the easy button, and cloud computing. and I will return to the Boeing 787. Asterisk is our artificial intelligence effort to capture what we have learned over the past few decades to leverage that knowledge in engineering future structures. Core Studios has also spun off software via Twin, our technology accelerator, such as Construe, our interoperability and collaboration software. And Swarm was spun off as well, a user-friendly interface for Grasshopper design and optimization. Swarm is really an app store for the design community. It connects designers who need easy-to-use tools with the super users who are building them. Swarm recently merged with Shapediver, a firm building Grasshopper tools focused on the product design industry. This is a very interesting collaboration, as there is much our industry could learn from rapid prototyping, modular assembly, and supply chains. This also introduces my fourth path, cloud computing, as Swarm is really Grasshopper tools in the cloud, but OnScale is a very high-powered cloud engineering tool, scalable to solve very large, complex analysis problems. And OnScale is suitable for all industries, not just ours. I return to the 787 to look at where we are going, considering our 2-decade lag per Chuck Eastman. Here are some paths that may be relevant to our building industry in the coming decade. The use of a single model throughout design and construction. Large chunks are design-built collaboratively. Extensive off-site prefabrication, material advances to improve performance, and the use of digital twins throughout the project lifecycle. Thank you for attending this brief presentation of my paper.